Okay, like we said, origin, that is where the x and y axes intersect. Starting point labeled with 0, comma, 0. And you can just rewrite that parentheses because it got lost down there. Kind of fell off the edge. 0, comma, 0. Does anyone know or have you heard of the word origin? In what context? Yeah, origin. Starting point, yeah. Naomi, do you have anything to add? Beginning, yeah, starting point. Great. Do any of y'all like Marvel, DC, superheroes? Yeah. What do all superheroes have? They have an origin story, right? So Superman came from kryptonite. Batman, parents died when he was young. A lot of superheroes' parents died, I feel like. It has a common theme in a lot of movies. Disney, yeah. I know. It was fine until I became a parent. Now it's like, what the heck? Anyway, origin story, right? So origin, start, beginning. So I'm going to write that over here. The start, the beginning. Begin, 2 N's. I think it's 2 N's. Or maybe 1 N. I don't know. 2 G's. There's 2 letters somewhere in there. That's going to be right here in the center of these two, the x and y axis. Okay, the origin. All right. Coordinate plane. That is the grid. We can see right there. And it's also called the Cartesian plane. Has anyone heard of it called that before? And do you know why it's called the Cartesian plane? No? Positive and negative number lines. So Cartesian, it's called that because the guy who came up with it, who invented it, his name was Descartes. And I know all of you are up to date on your 17th, 18th century philosophers. Yeah, Van especially. So he's one of the most famous kind of Western philosophers there is. He is the guy who said, "I think, therefore I am." Have you ever heard that before? Yeah. Okay. I totally disagree with that, but that kind of shaped a lot of Western culture and philosophy for, since he said it. So he really, really, really affected y'all's lives. So if you ever want to learn about him, you should. Anyway, I actually found this out from one of the other teachers, but the way he came up with this grid is kind of interesting. Strange story. He was sick, and I think he was actually I think he was like y'all's age. And he was just laying in bed because he was so sick he couldn't move. And he was looking at the ceiling. And if y'all look at the ceiling right now, you see how, if you look at 4 of the ceiling tiles, the squares, it kind of looks like this, like a grid. And then you have your axis going down the center, and the others, right? And he was watching, I think a fly was buzzing around. And he thought to himself, I could give someone the precise directions in the precise location of that fly if everything was just like a grid, and I could just count to the right and I could count up, or I could count to the left and I can count down. Okay, and it really is a simple concept, but it was kind of revolutionary in terms of making maps. I know y'all had in history class. Remember y'all had the prime meridian, the equator, all that. Longitude, latitude. That's kind of like the Earth. If the Earth was made into one of these coordinate grids, that's what it is, right? You just have longitudinal lines and latitude, longitude, right? So this red dot right here, right? If I wanted to have the exact location of it, I could say, well, starting at the origin, at the start, if I took a step backwards, or 2 steps backwards, and then 1 step to the left, I'd be there, right? If I took a step to the left and 2 steps backwards, I'd be there. So it's just a way of giving directions. Is the way to think about it. All of your maps on your phones, Google Maps, Apple Maps, Amazon have maps yet? I don't know. They all use a coordinate plane. So if you type in, what are the directions to Disney World, right? What does it do? It puts a dot on a map, and then it traces the road to get there, right? But the way that map works, right? It's a 2-dimensional flat map. It's basically a giant grid of the Earth, and it maps how to get there, pretty much exactly like we're going to map these points. Okay, this is kind of basic for it, but understanding how to plot points, that's understanding how maps work, how locations work, right? If you ever see like old war movies where they have radar, or not even old ones, but they have like sonar, maybe if you're on a boat or something, and you see that like it goes around and goes beep, beep, right? You see the little blip, beep, okay, and then it's beep, 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 and then the missile gets really close, and that's giving a location, and it's the same thing, same idea. Okay, so that, when he was a kid coming up with that idea, that really changed how people used maps and how they got places, and how it really opened up for a lot of new technological innovation. These 2 lines, right, we're going to talk about them a lot, and you all already know their names, X and Y. In fact, X and Y, for whatever reason, those are like the most famous math letters used all the time. The x-axis and the y-axis, right? Next unit, we're going to call them inputs and outputs. But for now, x and y. X is actually more familiar than you think. Okay, we did talk about them last unit, but even before that, the x-axis is really just your old friend, normal, flat, very helpful, but it's just your number line. Okay, so it's got positive numbers to the right and negative numbers to the left. So put a big negative sign there and a big positive sign here, right? We've already used it in a bunch of different examples for other topics. But that's when you see the x-axis, and if you look really closely, I know it's small, you can see the arrows at the end too, right? It's just a number line, okay? So if I said, where is 2 on the number line, well, you wouldn't really need to think about it, right? It's right there. Okay, you're just 1, 2. Where is 2 on the x-axis? I'm asking the same thing. 1, 2. Okay, so over here, where is 2 on the x-axis? 1, 2. It's just right there, right? Now the y-axis. This is kind of like the new thing, which I know you all saw this last year a little bit, but in terms of your progression of learning stuff, right? You learn the x-axis, just like we had with our number set, right? We said we learned when we were little, we learned how to count 1, 2, 3, 4, 5. Then we learned 0. Then we learn negative numbers, and then it kind of grows that way. Well, here we had this horizontal axis. Now we're going to stack it with a vertical axis. So instead of doing all that stuff on horizontal number lines, now we're also going to have a vertical number line where you still have 0 in the center, and then when we go up, we get positive numbers, and when we go down, we get negative numbers. Okay, and it's really as simple as that. Okay, and with 2 number lines, with 1 number line, you can only give directions on 1 dimension, right? 1 line. Okay, with 2 number lines, now you have so much more room, right? 2-dimensional, but anywhere on a flat surface, you can give the exact coordinates for. Okay, that's why we call it the coordinate plane, right? If I said, or I don't know, Tatum, give me a random number. 21. Okay. Van, give me a number. It could be positive or negative. Okay, so 21 would be somewhere over here, and then negative 128, I'd go down negative 128. And I could have an exact point for any 2 numbers you give me. Hi. Thank you. Okay. So any 2 numbers. And what we call those numbers are ordered pairs. ordered pairs. Okay, that tells the location on the coordinate plane. Right? How many is in a pair? 2. Okay, you got a pair of shoes, pair of gloves, parakeet, parachute. I'm just riffing now. Actually, I think that was on a SpongeBob episode. So x-axis, y-axis, ordered pairs. And one thing you notice, right? How many squares does this make? 4, right? 4 kind of areas. We call those areas quadrants with a Q. Quadrants. Okay? And we actually start up in the top right corner. That's quadrant 1. And instead of our normal number 1, for some reason, people decided it would be a good idea to throw in some Roman numerals. I think because they just like keeping them around. I honestly like Roman numerals. They're kind of cool. So 1, 2 is over here. So make sure you're doing those Roman numerals. 3. Do y'all remember how to do 4? 1 I, and then what letter? A V, yeah. Because V is 5, and if you have a line in front of it, that means -1. So it's 5 minus 1 is 4. Those Romans. So creative. Okay. All of the ordered pairs up here. In fact, let me actually we'll just do some real quick. 2, 2, 2, 2. Negative, what did I do? 1 and -6. And we'll do -3 and, I don't know, 1. And then how about 8 and -4. Okay. 2, 2 is going to be somewhere in quadrant 1, right? We go to on our x-axis. These are our x values. These are our y values. Always, always, always. X comes before y in the alphabet. X comes before y in terms of the axes we learn, right? We learn our horizontal number line and then our y. X always gets to go first, okay? I'm trying to think of another way to remember that. Oh, y'all probably wouldn't like that. Never mind. So 2, 2, -1, -6, -3, 1, 8, -4. Well, 2, 2 is going to be in quadrant 1, and we can plot it. This is kind of small, so if you don't want to, you don't have to. But it'd basically be 2 steps that way, 2 steps that way. -1, -6, down 1, and then down 6, somewhere over here. Quadrant 3, -3, 1. -3, 1, somewhere over here, quadrant 2, and then 8, -4, 8, -4, somewhere in quadrant 4. The reason I wanted to show you all these specifically is notice the positive and negative values. Both positive, always in quadrant 1, plus, plus. Both negative, always in quadrant 3, minus, minus. I always think that looks like a face or something. Minus, minus. Yes. Yeah, I see a sign your pass. Sorry. Go. Yeah, you can go wash your hands. I'll just sign it tomorrow. 2. -3 and 1. So whenever you have an negative x value and a positive y value, it's always going to be over here. So negative x's and positive y's.
And this double space.
Oh, you can go. It's fine. That was nice, though. Thanks for the offer. So 4 would be 8, -4, somewhere down here, right? But the point is, if you think about it like a number line, like let's go back over here. If I covered up the negative parts, I mean, this is kind of simple to think about, right? But everything on the number line is what? Negative or positive? Positive, right? So if we think about it the same way here, if I have a point anywhere on this side, of the y-axis. So like if all of our x-axis values are always going to be positive over here. So whenever you're plotting these points, anything in quadrant 1 or 4 is positive. And you don't need to memorize that. You just need to realize, like, if I'm covering up the negative values, same for our y-axis, right? If I cover up the positive values on the y-axis, then all of our y values will be minus. Okay? Thinking about it as a number line is much easier than trying to memorize that. All right. Ordered pairs, let's keep going. X, Y, X goes first. Go ahead and put a star there. All right? X goes first. And then Y. Okay? It's like ladies first. X goes first. Guys have a Y in their chromosome, so Y's go second. I don't know. I'm trying to think of more examples. X goes first. Yeah. All right. And again, that means that our like going left and going right directions comes before our going up and going down directions. X and then Y. Okay. Always, always, always. Slope. Slope is a measure of the steepness, which some of y'all said in y'all's warm-up, in y'all's lovely sentences, of a line over on a graph. And then I know y'all have heard this last year. The rise over the run, right? You're going to hear it a lot. Rise. In fact, I'm going to write it over here. Rise over run. And notice when we say over, just like I did with numbers this year, if I said 5 over 2, that's a fraction. Rise over run is a fraction. Okay? Ratio. Rise over run. All right. It's also, I want you to draw triangle y over triangle x like this. Does anyone know what that means? Triangle is means delta. Another Greek letter, delta. So draw an arrow there and say delta. And that just means change. So change in y over change in x. All right, so the rise is the change in y. And think about what that means, right? The change in y. How high are we going, right? I like to think of like an elevator. Going 3 floors up, okay? Versus over, right? The change in x. And then how far are we walking once we get off the elevator? Something like that. Okay, we'll do more examples later. Just get that down for now. Rise over run. All right, page 2. Let's go so slow with this class. All right, we're going to power through these. Y-intercept, that is the y-coordinate. Coordinate of the point where the graph of a line crosses the y-axis. Okay, this is really, and put a star next to this one, this is much more important than the x-intercept, for our purposes at least, for most people's purposes. The y-intercept, that's when our inputs are 0, when our x value is 0. So over here, trace over that line I printed because it did not print very clearly. What number is our y-axis being crossed at? See that line going through? What number is it crossing at? 3, yeah. So you're going to put b equals 3. And I mentioned this earlier, but b is the variable of choice for y-intercept. So b equals 3. And over here, go ahead and put b in parentheses. You'll see that a lot. All right, y-intercept. And again, something's being intercepted, right? That means it's come in contact with. I know not a lot of football players here. An interception, right? That's when the guy comes in contact with the ball, catches the ball. Okay, not the guy who's being thrown to, but same idea. You can think of like an intersection even of like streets, where streets cross. Okay, y-intercept. X-intercept, that's the x-coordinate of the point where the graph of a line crosses the x-axis. Okay, so basically it's the exact same thing. It's just for our x-axis. Okay, so here the x-intercept is 3, right? X-intercept is 3. But really, the y-intercept, that's the important one. X-intercept, not so much. All right, we'll finish up. Rate of change. That's just a really important concept we're going to spend more time on next week. But it's a rate that describes how one quantity changes in relation to another. A rate of change is usually expressed as a unit rate. And then a unit rate is a rate where the second quantity in comparison is 1. And so, last example, and then we'll pack up. Here, we have distance traveled on a highway. So you can kind of read a graph by saying, all right, time. In 1 hour, right, there's 1, I've gone 60 miles. In 2 hours, I've gone 120 miles. In 3 hours, so I'm going 60 miles per 1 hour, right? And that is where we get our 60 mph, miles per hour, right? Would it be, answer me this, which is faster, going 60 miles per hour or going 120 miles per 2 hours? Are they different? Are they the same? 60 miles per hour or 120 miles per 2 hours? They're the same thing, right? You could say either. Someone might smack you if you say the second one because nobody talks like that. We don't say, oh, I'm doing 30 miles per 5 hours, right? We say I'm doing 60 miles per hour. That's a good example of what a unit rate is, all right? The denominator is 1. So you can put those away. If you have time, you can glue them. But we do have 1 minute till the bell.